Hi everyone, this is Chandan. Today we are going to see window function in PostgreSQL, how we can use it. So actually a window function in PostgreSQL is used to perform some calculation over the row set of rows. So like a group by, we have a different group in our table. So here is the partition like group wise, and on that partition we can apply some window functions like aggregate function and perform that operations. So here is the definition. Window function is a PostgreSQL are powerful tools that allow you to perform calculation across a set of table rows that somehow related to the current row. Unlike regular aggregate functions, which returns a single value for a group of rows, window functions return a values for each row in the result set. So let's see the syntax. So syntax is function name. Then we need to give that some expressions over, and then we can apply that condition partition by and order by, and order by we can order some records based on that expressions, and range or rows we can specify. So let's understand one by one. So first is function name. There we can assign some aggregate functions or windows functions like sum, average, row numbers, rank, like that. Then we have a partition. So here we need to define the clause, divide the result set into a partition to which the Windows function is applied. So whatever the Windows function we previously put that in the syntax, that will be a partition of that records in our tables. And order by clause is normal. On each partition there should be some order. So after partition it performs that order wise. So it performs set of records order by, and then we have a rows and range. So here the clause specify the frame of the rows to consider for the Windows functions. So to perform that operations, we need some tables and some records inside a table. So I created one tables as a employee with employee ID, first name, last name, department, and salary. And then we need to insert some records inside the employee tables. So let's insert that. So here you can see 20 records is inserted, and let's see that first window functions like row number. So actually what it does, assign a unique sequential integer to the row within a partition. So let's see the example. Select employee ID, and then we perform that row number as a function. So here we need to give that partition by department ID, order by employee ID. So these records should be named as rows number, row number from employee table. So let's see, there is some spelling mistake. So here you can see rows number is for each set of records. There is row number 1, 2, 3, 4, 6, 7, then 1, 2, and there is a 6. So when you see the record for each department, so last name there is a department 1, 2, 3, 1, 1, 2, 2, 1, 3. So let's see the table. So here you can see all the record and then row number. So it will be a better idea. Each, I hope you understand that. 1, 2, 3, 4, 5, 7, and then you create that. So it there is a department by order by department. So it is generated that row number for each department. So there is a 6 records in third number department and 7 records in one number department, just a number for a department. So let's see that rank functions. So here is select employee ID, salary, rank over order by salary descending order as salary rank from employee. So there is no partition. So partition is not required here. We just need to give that order by. So basically it does. It's similar to the row numbers, but it gives the same rank to the rows with equal values. So let's execute. So it's a rank. So there is a 20 records. So you just give the 20 record salary rank and it is ordered. So it is a first rank, second. So it's a maximum salary is 95 and that, and here you can see both record are same, so it's given that same record two times and the rank is the same. So it is a different use case in when we implement in our real type program. So let's see the dense rank. So here is a employee ID, salary, dense rank over order by salary, descending order. All the things are same as rank. There is just given that dense rank, execute that. So dense rank, what it does, it's similar to rank, but it does not leave the gap in the ranking sequence. So previously that that was skipping that. So let's rerun and explain to you what is the problem with the rank. Not a problem, it's a use case. So here you can see there is a 1 2 3 4 5 6 7 8 8 and then should 9 and 10. So it two raw map with 8 and then skip that 9 and it started 10, and in the dense rank it will won't happen. It will be the rank, it won't provide that gap. So whatever the, so here you can see 8 number records are 72,000 and then 71,000 is ninth rank, so on. So here you can see 60,000 and it won't escape, it started from 1780. So this is the main difference with the dense rank. And let's see some aggregate functions. So select employee ID, department ID and salary and sum of the salary over each partition of department. So if there is a 3 department, that will be a 3 group of records, and on that the salary will be performed as a, and it will depend returns as a total department salary. So each department has different salary, total salary, and we can calculate like that. So let's see the example. So here you can see there is order by salary descending order. So each first department salary is 42 lakh 8,000, 42 4 lakh 28. Yes. So for each department there is a first department records and then department records and then it third department records. So here you can see that. So this is the, we can perform each group aggregate function. Similarly, we can also provide that, execute that average function. It's also similar. So we need to give that average here and average department salary. So average salary is this for first department, second department salary is this one. Okay, like that. We just given here average salary and all the syntax are same from the above. So I hope you are aware how sum and average works if you are here, because it's part of aggregate function. So let's see the lead and let's see the understanding on the lead. So what lead does, it access data from the next row in the results. So employee ID salary and lead salary from the next record, like first it keep and from the next record it access that give the next salary. So salary and next salary 65. See the example. So here you can see next salary is this one, and then last will be the null. So this is the main difference with the lead, and similar is lag, which will provide previous salary. So lag function, what it does, it access the data from the previous row in the results. So it, for the first record there is no previous, so that will be a null, and then it's starting from giving that 60,000 65,000 here. So let's see the example. So here you can see for the first record there is no any previous record, so that's why it's null. And for the second record there is a record which is a previous 60,000, and here you can see previous record 8,000, and so this is a lag function. So I hope you understand how lag works. And there is one function NTILE with n. So what it does, it divide the result set into n buckets. So inside a bucket there should be a records and assign a bucket number to each row. So each bucket, like n is a n number of bucket, and then assign that as a bucket number. So here is a 4 buckets. So let's execute that. So salary. So here you can see order by salary. So for the first bucket there is a 4 types of record: 62, 60,000, first, second, third, and fourth. 4 types of records in one shape. There is 1, 2, 64. Actually, it divide the n number of buckets and assign a bucket number to each row. So here is the row number of each bucket. So here you can see 4. 1, 2, 3, 4. For the first bucket there is a 5 record. Second bucket have a 4 record, and third bucket has like 11 to 20. So it's a 10 record. Okay, to understanding 5 and see that. So here you can see for the record there is only 4 records, 4 and then 3, 4, 2, 2, 4. So 4 records present here. So 4 into 5 equal to 20. So that's why it's distributed that in 4 bucket. So you can also specify the frame for the window function using rows and range. Let's see the example how you can specify the frame. So in the window function there should be some frame. So it works on the frame. So order by employee ID, rows between 1 and preceding and current row as a total employee. So like that we can give that frame rows between 1 and preceding of current. Okay, so 60 and 65,000, 125,000, and then 65 and 70,000 it will become. So it's between 1 and current row. So it's combining that 2 records and putting that real. For the first one there is only 1 record, so that's right, 60,000, and here you can see 70,000 and 72,000. It becomes 70, 70, 14 and 2,000. So 1,42,000. So similarly, it will give that frames combining records. So window functions is a PostgreSQL provided by the powerful way to perform that calculation across set of rows related to that current row. They are particularly useful for analytics and reporting tasks, allowing you to derive ingest for your data without the need of complex subquery or join. So to avoid that subquery or join, we implement that window functions by knowing that how it works and what is the use of lag, frame, lead, average, sum, dense rank, close number. So I hope you understand that. That's all for today. Thank you for watching.